Good morning, everyone. If you'll take your seats, we'll get started in just a second. Well, good morning and welcome to the third and last day of our 3D Digital Documentation Summit. We're glad to have all of you back early this morning. I have a few thank yous we'd like to go through since this is our last morning together, and some of these people we thanked as a group but not individually, and so we'd like to call out some people that have been particularly helpful to us in putting this together. First of all, from the Presidio Trust, both Hans Bornal and Kelly Wong. I saw Hans here, he's in the back. Raise your hand. And is Kelly in the room? But anyway, they've both been tremendously helpful in getting this together. And then the Western chapter of APT that sponsored our opening reception, Chris Gray and Molly Lambert from there. And also from Leica that paid for that reception, Joshua Van Diver. And then I haven't mentioned the Friends of NCPTT. This is our new 501c3 that supports the work of the National Center. And this is really the first joint project we've done with them, and they're the ones that made it possible for you to pay with a credit card, which we've never been able to do before. They're also providing the food for you today, which is, for those of you who are in the federal estate, you know that's a difficult thing to do. So we want to thank our Friends group and Tommy Whitehead, who's the president there, for making this possible for us today. And then several people have mentioned that they like the caterers. So for those of you who are local, they're called Aroma Bueno, and Ivan Valencia is in charge of that today. We've been pleased with the support when you do long distance training events or symposia like this, and you're arranging these things. You never know what you're going to get with local caterers, but I think they've done a good job for us, so we appreciate that. Okay, we're ready to start with our first paper this morning, and I want to introduce you to you Bob Warden, who is a professor of architecture at Texas A&M University, and he's also the director there of their Center for Heritage Conservation. And Bob's resume is too long to give you this morning before he speaks, but he holds degrees in electrical engineering, in architecture, and in philosophy, and he's been working in heritage documentation since 1985. So Bob, we welcome you to talk to us about why digital. Thanks.
See, you're lucky it's only 3 pages and 150 slides. No. So keep me on track. Sometimes I get wordy. Well, thank you. It's great to be here, and I always look forward to talking about things that we do. I do direct the Center for Heritage Conservation at Texas A&M, and our mission there is not unlike the mission at most universities where you have a mission of research, teaching, and service, although we tend to call it something slightly different. So we have a mission of research, education, and outreach, which the differences are subtle, but we think are important. And also, unlike universities where there's a hierarchy of that triad where you get advancement in the university by your research, not by the other two, teaching and service. In the center, we try to take a more egalitarian approach and treat the three equally. So the research, education, and outreach is very important in every project that we do. We try to treat each project as a unique combination of those three, almost like ingredients in a good stew or soup, so that the output of the combination of those is something new and different and unique, rather than just a project that is this group or this group or this group. Now, the great thing about good research, as we learned from the opening presentation, is that it changes people's lives. And it changes people's lives through the questions that are asked, the education that's required of the research, and then also in the benefits to the public of the products of that research, even if the public doesn't realize that they're benefiting from it. So heritage conservation research, it may not be an iPad, may not change people's lives or people don't perceive it as changing their lives like they might see an iPad changing their lives. But we can all probably remember visiting an historic place when we were a kid, even if, and getting a thrill out of that, even if the thrill was not because of the place, but because we were on vacation or we were having our family there, or even maybe because we had a hot date at that historic location. Now, documentation is the foundation of all heritage conservation, and as such, if you look around today, we tend to treat documentation well, seriously, in the sense that we document everything. I mean, we take wedding photos and baby pictures, and we create baby books and family pictures and gymnastics pictures, and we write journals. And now with Facebook, we even document what kind of coffee we had at a coffee shop at a certain time in the morning, or we're sitting at the doctor's office and we say, I'm at the doctor's office and I'm thinking about you, we seem to document every minute of our lives. So it's important, but it's now ubiquitous. One of the points I want to make about heritage recording is that I call it recording and documentation because they're two separate things, and that's the research and communication of the stories that we had to tell, and not the stories about things. They're the stories about people. The objects that we're dealing with are cultural objects, but the stories that we're telling about them are really the stories of the people who gave birth to those objects, or the people who kept those objects alive, or the people who eventually killed those objects. So as we go through the process, what's required of us is the creation of this collective memory of the people involved in those particular places. And we have a great responsibility because of that, because heritage is a public item. It's not my heritage or your particular heritage. It's our collective story, and that's an important story to keep. And it's our responsibility as recorders and documenters and storytellers to get it right. And so what I'm going to take you through today quickly is sort of our thinking in the center from our work starting in 1985 as we face these technological barriers or opportunities, depending on how you want to look at them, and just give you a few thoughts about what we were thinking about as we go through and where we've ended up today, and then maybe we can have a conversation about that. So the traditional communication tool for our heritage, at least in the U.S., has been HABS. And one of the things that occurs in a HABS project, at least with traditional measurement techniques, hand measurement techniques, is that we notice that the real concern is the dimensions. And so we are concerned with relationships of things on the object rather than particular points, but we choose those points because we're interested in the relationship. And of course, the requirement of hand documentation is that you actually have to put a tape one place, so you're touching the building in one place and you're putting the other end of the tape, whether it's the dumb or the smart end. There is no dumb and smart end, as we all know. And then you actually begin to understand the heights of things and relationships of things, because if you have to get on a ladder, you get that feeling of being in a precarious position to reach the eave of the roof. All of that is information that goes into your understanding of that particular building. And that's important information that comes out and creates the story in the end. The drawings and the preliminary drawings that you make in the beginning to understand a particular object lets you know something about the people who made that object. And you get an amazing sense and relationship with the building that way. Well, in 1985, we started a project in southern France, not because we wanted to document the building. Actually, the documentation was a requirement of a historical study. So we were looking at construction campaigns on this cathedral, and the idea was to document it very carefully, all the way from the smallest rib profile to the largest dimension. And when we started doing that, and we were documenting by hand and drawing by hand, we noticed that the pencil width was a greater error than we could possibly deal with in our study. So we decided to move to CAD at that time. It was AutoCAD 2.5, and at that time it came on a little single 500 and I guess it was a 520K floppy disk. They didn't have the hard shell 1.1 meg floppy disks yet. And so what that gave us was the opportunity to create a plan that contained all the detail within the single plan. So as long as we were the ones doing the study of the building, then we could move and include all the detail in the plan. I was working with a historian, so I'm not a Gothic expert, but the historian was a Gothic expert. She wasn't a measuring expert, so we teamed up, and that's the way we did it. Most of our documentation work was done by trilateration by hand and drawn on paper in order to do a check on the dimensions, and then later translated into to CAD, not traced. We did try digitizing from a tablet, but it was actually more accurate to just work off of the measurements. Challenges of scale. This is the south elevation. This is the view you get. So obviously there's a lot of occluded views. So at that time we were using two theodolites with vernier readouts, so they were really kind of ancient tools. And we used those to point at the same point, make sure we were looking at the same point, and then did all the calculations in order to produce a 3D view. So there's some of our sheets and the sketches that we would do at the time to get the elevations. And then the scale inside was the same typical problem, but that allowed us to do a CAD elevation where we could begin to get the detail within the elevation and then do comparative studies. In '98, that took a long, cathedral took a long time, so we were doing other things, but '98 we did our first HABS project that involved CAD, and it was a slave quarter, and there was some trepidation about that, not from our part really, but the issue here was plotting, because getting the digital output onto an archivable print, and this was at the electrostatic plotters were just getting ready to go out of style, and inkjets were coming in, and there was no archivable ink for inkjets, and so that was the trepidation for that. In 2002, we were asked to document for HABS Montezuma Castle, and of course, being a cliff dwelling, it was a challenge, and so remote sensing became an issue there. We had thought about laser scanning because early in 1999 at the Goodrich House in Anderson, Texas, we had used a Cyrax scanner as an experiment to go along with our hand measuring and the photogrammetry that we used on that house. Given the size of the equipment at the time, we decided to abandon the laser scanning and go with methods that we were familiar with. So we used a reflectorless total station, which were pretty ubiquitous at that time, and used the total station as control for laying out hand measuring datum lines within the interior and exterior of the building, so that students could begin the trilateration on the inside. And so we had a total station group that would work with that, and then other teams working on the hand measuring on the inside of the building, which was a challenge because it was dark. And then we produced the HABS set in CAD. And so, and the production issues on this, of course, were now you didn't have electrostatic plotting. Stippling was the traditional way of rendering shapes, and so we did this by line drawing, and then plotted the line drawings out on Mylar, and then hand stippled the Mylar too. We tried the digital stippling, and I won't go into the issues, but there are many. You can do it, but it's more of a hassle. We were much faster in hand stippling. This just shows you a field drawing that we did at that point. And this is one of the 3 sections that we took through the building. I'll bring up a quick point here that when you're working in this way and you're creating drawings, you have to be strategic. You have to have a plan that what you're going to draw and measure, and then you stick to that plan because time being what it is, you can't measure everything. This was a recent project in 2009, another HABS project for the St. Andrew's Episcopal Church, but this was our first inclusion of scan data with a HABS project. And again, we're using all measuring methods. So we start out, always we do hand drawings, always do hand drawings, and that is because it's important for the education to understand the building. And we spend that time, which is not that much time. I realize if you're professional and you're doing it, a few days seems like a lot of time, but it really helps in telling the story. We were fortunate in this project. We did photogrammetry and scanning in the interior and exterior of all the stained glass windows, and we had just completed that 2 days prior, and they had some vandalism and completely destroyed 2 of these windows, and we were fortunate we had the data so we could reconstruct the windows for them. And just an example of scan clouds. The scanning actually was a redundant information source for us on this, and we actually use all of our measuring methods as a redundancy to check and cross-check everything that we do. If we get confirmation from between hand and total station, photogrammetry and scanning, then we know we've got it right. And as I said before, it's important to get it right. And here's one of the drawings there. This is a battlefield, a Normandy battlefield site in Normandy, France, Pointe-du-Hoc, a famous battle on D-Day. And we had been working there on a historical study in 2003, 2004, and we were asked to complete a stability study of the cliffs at this site because one of the bunkers, the observation post, which is one of the bunkers right on the tip there, that last one right on the tip, had been closed since 2001, and it houses the memorial to the 2nd Ranger Battalion, which is something that the nearly 1 million visitors a year go to see. It's the thing that everybody goes to see, and it had been closed to the public for 10 years because of the cliff failures below. So they had asked us to do that. So this is where, and this was in 2006 when we started this, and we did a lot of coring information, and we had a geophysicist with us from A&M who did resistivity studies, 3D resistivity studies, and the idea behind the eventual laser scanning was to combine this data together as a visualization tool to help the French understand what was going on because they're the ones that closed it, and to help the U.S. government understand what was going on because they were accepting the liability for reopening it again. And these are a few images that show the setting of the lines on the cliff. The resulting resistivity, which really shows the flow of groundwater, and we created a number of these fence diagrams, put them together, created, this shows a sort of a 2D view of all the resistivity lines, and then created a 3D model of the resistivity, and then combined that 3D model later with the laser scan data that we did of the site. So we did about 30 or 40 scans of this site. The theory was that the causes of the failure were the caverns, limestone, the dissolving of the limestone at the base from the groundwater, not obviously from the North Sea, which is salt water and it doesn't dissolve limestone. So it was the fresh water seeping through that would dissolve the limestone, and then the force of the seawater would take the rocks away. And so they had these huge caverns in there, and so we had to find out how deep they were and what their proximity was to the observation post. So we used laser scanning in order to get us an overall view of the cliffs, and then some detailed views. You can see some of the basal caverns down below, and to try and understand the proximity of those to the observation post, which you can kind of see with that memorial spire on top. And we did this by creating sections and then marking those sections and relating those to the survey and also to a historical study of the cliff erosion since 1945. Wrap this all up, combining the 3D resistivity with the laser scan in order to corroborate what was going on. And then presenting that in various ways, 2D and 3D and volumetric studies of that, so we could demonstrate exactly what the proximity was for each of these things. We happen to have some photographs from the movie that was shot The Longest Day, and the lighter area shows the stuff that had eroded since 1945. And so I'll wrap up here quickly since I have 39 seconds. We're also working in Belize, working on some Maya archaeology, and this is where we're doing some structured light scanning of stela and the Maya script that's on there, and working with a Maya expert so that he can look at the models that we produce and to make sure that the meshing is correct enough, because apparently, I'm not an expert in Maya script, but there are very subtle changes in letter forms and pictorial forms that change meanings from one thing to another. And so the meshing has to be very carefully done. And some laser scanning of that, and then also photogrammetry of special finds. And we were doing this to prove to the archaeologists that with the photogrammetry, and this is that disc is about 6 centimeters across, and the inlays carved into this disc were just millimeters deep, and we wanted to create a 3D model of this so that we could show the archaeologists that you can study this in 3D if you just learn a little bit about how to manipulate it. And the photogrammetry was able to capture the inlays. So the top picture there is a photograph, the bottom picture there is a meshed model. So, what do we know? What do we learn? You know, the big thing about documentation is keep your eye on the prize. Why are we doing this? What's the story that we're telling? We tend to get lost in the details of the technology when, in fact, what we're really doing is trying to tell a human story. So, make sure that new objects, new thinking, new interpretation comes out of everything that we do, and it doesn't really matter. Use the tools that you need to use, but also combine them so that you get it right, and use them in a way that's going to best inform you about the building so you can tell the best story that you can. So what can we say about 3D digital documentation? Well, it's not just ones and zeros, so that's my point. Thank you very much.